sometimes when we factor special patterns. This is one of them called the difference of squares. The thing, or how we recognize difference of squares, is it's something that will always have two terms. So just two terms, and then the difference means you'll have subtraction, so you'll have a subtraction sign. And then squares, those are going to be your perfect square numbers. So we're subtracting two terms of perfect squares. Now a perfect square is, let's see, 1 squared equals 1. So 1 is a perfect square number. 2 squared is 4. So 4 is a perfect square number. 3 squared is 9. So 9 is a perfect square number. So you kind of get, we can create a list of our perfect square numbers. 1, 4, 9, 16, 25, 36, 49, 64, and this list goes on and on and on. These are also numbers that you can take a square root of evenly. That's another way to think about it. So to recognize the difference of squares, if that's the type of factoring that we're asked to do, we want to look for two terms with subtraction where both terms are involving these numbers over here. So this first example, you can see we have x squared minus 64. So there's your two terms, x squared and 64. So far it fits for our difference of squares. It's subtracting, so that's good. And then the other thing is, did we square anything to get these two terms? Well, x squared, that's like squaring an x. We took an x and we squared it and we got 64. I'm sorry, we got x squared. Minus, now do we square anything to get a 64? And we do. We can square an 8 to get a 64. So we're going to use the x and we're going to use the 8 in our difference of squares pattern. Now the nice thing about difference of squares is it's really easy to factor as long as we can just remember how the pattern works. So you can go to your two sets of parentheses right away. Your x goes first, whatever you squared right here. And then in the second term is going to be that second number. You're going to have an 8 and another 8. Now the only thing that we need to remember here are the signs, and they're going to be the same signs every single time. One of them gets a plus and the other one gets a minus. If you notice, when we have our x squared minus 64 up here, this is a binomial. We're missing the piece that made it a trinomial. Really, it's like an x squared plus a 0x minus 64. And if we think about foiling out what we have over here, you know, x times x gives us the x squared, and then your outside terms, the negative 8x and the positive 8x, add up to give us that 0 term. That's why those opposite signs are really important. But if we remember how the pattern works, we can just go straight to our answer like that. Alright, next example, we have x squared minus 81. So we have two terms with subtraction, so maybe it's a difference of squares. And then we just say, alright, well, did we square anything to get each term? This is an x that's been squared. And then is 81 a perfect square number? And it is. We squared a 9 to get that. So we can go right to our answer. We're going to have an x plus a 9 and then an x minus a 9. And that's our factored answer on that one. So these bottom two look a little bit different, but they're not that bad. You know, again, is it a difference of squares pattern? You've got two terms with subtraction, so far that looks good for difference of squares. And then did we square anything to get each term? Well, if you notice, 4 is a perfect square number and 9 is a perfect square number. So this is like if we took a 2x and squared it, and then if we squared a 3. So it's the 2x and the 3 that are going to go into our factored answer. We're going to have 2x plus 3 and then 2x minus 3. And that is our final answer for that one. So again, really nice. They go quickly. We just have to remember how it works. Last example, two terms with subtraction. You've got a 36 and a 25. Those are perfect square numbers. Also, x squared is a perfect square term. So what did we square to get each one? This is a 6x that we squared, and this is a 5 that we squared. So 6x and 5 is what goes into our factored answer. We're going to do a 6x plus a 5, and then a 6x minus a 5. So difference of squares, two terms with subtraction, where both terms are perfect squares.